And today we are going to start with the second point, that is of routing. What is the meaning of routing? What is a router? What is the meaning of route? Route is nothing but it is going to see the path. It is going to show the path in which direction it has to move. In day-to-day life, we are seeing this example, the route. If you ask someone, I have to reach that particular destination, in which route I have to go? You have many routes. You have many routes, and you are going to choose the better route, which is better for us. Similarly, the functionality has to be taken care for this routing. Router, what is the router of this? It has going to decide the particular destination. It has to decide the particular path, and that decision has to be taken by the algorithms. The routing algorithms has to be decided by the routers. Okay, and it is going to, these algorithms has to decide the particular path for reach the particular destination. That is the meaning of routing. Which route is good, which route is bad, that has to be decided. Once you are traveling in somewhere, you started opening the app that is of Google Map. That Google Map will show you the better route instead of that the kacha rasta. That is, Google Map will show the better route. That is the shortest route it is showing. The road is good or bad, that has to be shown by Google Map. How much is the kilometers there to reach that particular destination? Similarly, this route has to be taken place on the network layer. The routing and the routing algorithms is going to decide which destination, which path, which route has to be taken up for a particular packets. So it is the selecting the path along which the data can be transferred from source to the destination. Source is initial and the destination is the final. And the routing is performed by a special device known as a router. We are having the router table, a routing device. Routing device is using the routing algorithms. These algorithms is going to decide the particular routers. And it is working on the OSI layer, and it is working on the network layer of OSI model. That is, it is mainly working on IP address and or the TCP, transmission control protocol. And router is a networking device that forward the packets based on the information available in the packet header and forwarding the table. Routing is what? In that particular router, for example, you are sitting in a particular bus, and thus that bus has to carry you to particular destination where you have to reach. You have to sit that particular bus itself to reach a particular destination. You are going from Pandharpur to Solapur, you have to sit that particular ST bus that from which is going from Pandharpur to Solapur itself. You can't sit for other bus. You can't reach that particular destination. That the similar example has to be decided by this routing technique. Who is going to decide this? Similarly, for this similar examples, that is the routing algorithm has to decide the routing path. Okay, and ST buses, that has to be decided by particular buses. These buses will be goes to the particular destination. So that has to be decided initially. Initially, that has to be decided so that all the peoples has to reach that particular destination. That has to be done by this routing algorithms. It is a software responsibility for deciding the optimal path through which packet can be transmitted. Optimal path is nothing but the decided path in which route it has to be sent, the particular packet. That packet has to be sent through the best way, best path. That is a better way of that particular direction. It has to be measured. How much is the weight of that particular packet? What is the bandwidth has to be used for that particular packet? How much delay has to be taken to reach the particular destination? What is the load of that particular path? Load is nothing but how much the distance same, and it has to be decided by before sending that particular packet. The routing algorithm has to be decided the particular destination to reach the particular optimal path. And this routing algorithm initializes and maintains the routing table for the process of path determination. The routing algorithm function is to initialize the routing table. Once the routing table has been initialized, through that routing table has to process the path, which path this packet has to go, and in which path another packet has to go. That has to be decided by this routing table. And the next point of this is principle of optimality. What is the principle of optimality? Here he has given some of the examples that is nothing but the path is shortest or a path is longest. For example, he has mentioned from J to K. Here you are saying J and root K. It is fixed. These two routes are fixed. You have to reach J here, and from J to you have to reach a K. It has mentioned that between the router J and the router K, and a path from router I to router K. From it has to be moved from here. It is showing the green color over here. If you want to reach from the destination K, there are many of the routes we are saying. If you reach from K, from I to K, this one is the route I, H, L, K. And one more route you have, that is I, G, J, L, K. And one more route is there, I, G, J, M, N, K. This one is the shortest route we can consider. This one is the shortest route we can consider. This one is a little bit longest route. This one is a little bit longest route. And this one is too longest route. Many of the nodes, many of the links has been connected. Many stations are connected between from I to K. From I to K, the many stations are connected between I to K. The less number of stations has been connected between I to K from year to year. So this is what one of the examples. If you reach from I to K, the green color has been mentioned over here. This is one of the route. If you want to go from I to K, one more route is there, that is I, H, K, L, K. One more route is there, that is the longest route, I, G, J, M, N, K. Similarly, they has written here. The optimal path from J to K will again lie on the optimal path from I to K. Means from these, the alphabets for J and K are lies between I and K also. If the initial point is, if you consider the initial point is I and the destination point is K, there is a longest path you are considering. If you consider the initial point as J and if the final point is K, there is a shortest path you are considering, J, L and K, J, M, N and K. The two stations are arriving over here. Only one station is arriving here. This packet has been reached suddenly. Immediately this packet has been reached for a particular destination. This packet is going to take some of the time or some of the delay to reach a particular destination, because we are having the two stations. It has to cross the two stations, that is from J to M, that is from M to N and N to K. Similarly, he has mentioned over here, consider a network of routers. This is called as a routers. Some of the network you can K, the one network is I, G, J, H, I. This is one network. Second network H, J, L, K. The complete graph that is called as a network. The complete graph that is called as a network. The one more network is L, J, M, N, K and L. This is called as a one more network. The many networks, if the graph becomes complete, that is called as a complete network. That is called as a complete network. If it is small network or a big network, that is don't matter. That is won't matter if it is a small network or a big network. Okay, that network is going to cover a full graph. The routers is G, H, I, J, K, L, M, N. G, H, I, J, K, L, M, N. These are some of the routers we can say shown in figure. Like the optimal route from I to K. This is the initial point and the destination point we consider is K. That is has been shown in the green path. Only one example he has shown for reaching for reaching from I to K, the green color has been mentioned. So via route is nothing but what? If you are moving from Pandharpur to Solapur, in between you are getting some of the villages. Those villages are called as the substations to reach a particular destination. Substation to reach a particular destination. That is called as what? In between the initial stage to the final stage, we are arriving. We are going to cross a substation. Those stations are called as a subroutes. Via, that is called as we are going through some of the routes. According to the optimality principle, the optimal path from J to K will be along with the same route. Same route. There are a number of routes are there. If you want to move from Pandharpur to Pune, you have many of the routes. You have many. You can go through Tembuni also. You can go through this. Another way is there. Which route is better? That route that has to be considered. So that is what. If it is shortest route, that shortest route has to be considered first. And if it is longest route, we can think of that longest route so that we can send the particular packet. So similarly, we are going to see in this. Similarly, we are going to cross check over here which route is too small, which route is medium, which route is big. That has to be considered over here. And one more example he has taken. This is the shortest route from reaching from I to K, reaching from I to K. One more example. If you want to reach another route, if you want to reach from initial stage to the end of that particular stage, another route, that is from I to K. You are taking from here, you are taking from I, G, J, L and K to reach a particular destination of K. In this diagram, to reach a particular destination K from the initial stage of I is going from I, G, J, M, N, K. So this is the longest route. It is going to cross many of the routes. It is going to cross many subroutes. That is called as a particular routing. Which route we have to take to reach a particular destination? One more is there. To reach a particular destination, that is I, H, L and K. This is the shortest route we can say. This is the shortest route. Instead of that, we can move from I, H, J, M, N, K. This one is one of the route. I, H, J, L, K. You can cross, we can make many of the routes to reach a particular destination from the initial point. So this is what one of the example, how it is going to mention, how it is going to consider the particular route in the routing table. Routes in the routing table. In that, we are going to have the first point, that is of shortest path routing. Shortest path routing. Shortest path routing is nothing but which network has taking the shortest path. Which network is taking the shortest path. With the minimum distances, we are going to reach a particular destination. That is what it is. Here we are going to consider, this is the initial stage. If you want to reach from B to C, which is the route? The shortest route is B to A, A to C, B to A, A to C. If you want to reach one more route, B, D, E to C. One more route, B to G, G to F, F to C. These are some of the routes to reach a particular destination. We are considering the destination as C. See, one example he has mentioned, the shortest path between B and G is B and G. We can't connect directly. We can't connect directly. So in between, we need required substations. We required a substations to, that is called as a shortest. B to G is nothing but what? How it is? B, D, E, F, G. B, D, E, F, G. Or B, A, E, F, G. B, A, C, F, G. There are number of networks we are going to get, but we can't connect from B to G. It is not from B to G. So that is what the one of the point we are having here, that is shortest path. Which is the shortest path that is to be considered over in this. The shortest path routing refers to the process of finding the paths through a network that have a minimum of distances or other cost metrics. Minimum of distance is nothing but what? We require minimum distance with the cost is less to reach as early as possible. That has to be decided by this shortest path routing. And while deciding this shortest path routing, you have to decide the cost, how much cost it is required to reach a particular destination. The main purpose of this shortest path routing is make the source node as permanent. Source is nothing but initial stage. You have to make it as permanent. We can't change it. Once you make it as a permanent, we can't change it, because it is this. If you make it, this is as the initial stage, B as the initial stage, we can't change from B to A. We can't change from B to N. Already decided that the packets has to move from B itself, from the route B itself. We can't change from B to A route. It has been decided initially. If you have decided the route as A, that is A itself, till the end of all the packets to be reached at the particular destination, you have to decide that the particular A has been decided. Designate the source node as the working node. So this is what initial stage we have decided. So that initial stage of that source node as a working node, it has to be working. Set the tentative distance to all the other nodes to infinity. Infinity is nothing but any packet, any data can be sent to any of the route, so that we can't say that this much the distance is required to reach a particular destination. We can't say that. So that is to be considered as infinity. That has to be considered as infinity. The tentative distance from the source to all the nodes adjacent to the working node. Adjacent to the working node is nothing but what? We are sending the packet from B. In between there is some nodes are there. These nodes will be working nodes. If some working has to be taken place over here, it has to be managed for alternative link. It has to be managed for a alternative route. Alternative route is nothing but whenever you are moving, for example, in a real example is nothing but you are traveling on a road. If a work is going on the road, he has mentioned the diversion. Take diversion. So the work is going on. It is under maintenance. So like this, if that route is busy, you have to move from B to A to E, E to C. Instead of B to D, D to E, and E to C. So that is what all the nodes should be in the working node. If this is shorter than the current tentative distance, replace the tentative distance of the destination and record the label of the working node there. If that maintenance has done in a particular period of time, you have to remove that particular node immediately. Okay, that is what comes under shortest path. These are one of the some of the examples he has mentioned here. That is, it is to be acting like a hexagonal. Okay, if you A, B, E, G, H, D, C, this is the initial point. You can consider any of the destination point. That is from, if you want to move from A to D, which route? There are many routes you can consider. That is from A to B, B to C, C to D, A to B, B to E, E to F, F to C, C to D, A to G, G to E, E to F, F to C, C to D. Another one, F to H, H to D, A to G, G to H, H to D. Now S to F, H to C, C to D. These are some of the paths. These are some of the paths are going to decide by this particular destination. Okay. So these are some of the examples for a shortest path distance can be decided by the particular destination. This is shortest path algorithm. And there are some of the types of routings we are going to study in this. The types of routings are nothing but what? Types. Route. This route is fixed. This route is fixed. By default, you have to go by this route itself. The route is fixed. You have to go by this route itself. If that route is not good, you have to take alternative route that is by default. By default. If that route is a maintenance, it is a working condition. So by default, you have to take the turn and reach to the particular destination. That is default. Dynamic, any route you can take. That is not fixed. Static is fixed. Static is fixed. Default is in that fixed routing, you are going to take the another alternative route. Alternative route. Dynamic is the route is not at all fixed. We can take any route to reach a particular destination. So that is what the meaning of this routing. The three types of routings we are going to study over here. The first is static routing, default routing, dynamic routing. What is static routing? The static routing is also known as a non-adaptive routing. It is not adaptive. Adaptive is dynamic. Adaptive is dynamic. It is already adopted. It is not adaptive. Why? Because it is not adaptive. Already the administrative of that particular router has fixed the particular routing, has fixed the particular routers, has fixed the particular routing table. Based on that routing table, based on that routing, the particular data has been sent. So that is what called a static routing. It is a static routing is also known as non-adaptive routing. Non-adaptive routing. So it is a technique in which the administrator manually adds the routes in the routing table. Manual is nothing but he's going to write a particular routers. He's going to write a particular route, which route it has to be go. Manually is going to write. We are going to write a particular student name. This student has to go by this way. This person has to go by this way. This student, these many students have to sit in that particular classroom itself. This is SYA classroom, this is SYB classroom, this is TYA classroom, TYB classroom, LYA and LYB. We have did it. We have manually did it. So based on that, all the students have moved to that particular classroom itself. You can't move, you can't sit from LYA to LYB because your name is there. Your name is included in that particular LYA itself. You can't sit in LYB division because it is already done it. Previously, it has mentioned it from the initial stage. From the initial stage itself, it has been made it. You are an A division, so you belongs to only A division, not belongs to the B division. So this is what already this administrator, the owner, has manually adds the route in the routing table. That has to be done by this static routing. A router can send the packets for the destination along the route defined by the administrator. The function of this router has to send the packets to the destination, which route has been mentioned, which route it has to go for the particular destination that has to be mentioned in that particular routing table. And in this technique, routing decisions are not made based on the conditions or topology of network. It is not based on the conditions, is nothing but initially it has been decided. So based on that decision, we are going to do the particular work. So that has to be done on this static routing. And advantages of static routing is nothing but what? If you are fixed, if your name is fixed in particular division, you don't get any problem. You don't get any problem. If we are moving your name from one division to another division, you are getting headache. In which division I have to set? So there is no headache. There is no have overhead for this particular. It has no overhead for the CPU usage of the router. Therefore, the cheaper router can be used to obtain the static routing. The whatever the cable we are using for this static routing, that is cheaper. The bandwidth which is using is used between not, it has not bandwidth usage between the routers. Once it is fixed, the bandwidth has been fixed. We do not require the more bandwidth as required for this. Security is good. So why it is security is good? Initially, the administrator is going to decide which route it has to be forwarded, which route it has to be forwarded the particular packet. So the security is very high. The controlling is good, in which it provides the security as the system administrator is allowed only to have a control over the routing to a particular network. In that particular network itself, that has to be controlled by this particular router. What are the disadvantages? If the network is large, we can't add the route in this. It is very difficult to add the route manually in the routing table. If immediately the students become more, it is not possible to write all the names immediately and manually. If the software implement is there, a software has take immediately by capturing the particular image of that particular icon of that particular person. If the software installed, if it is manually, it takes time. It is very difficult to add the particular all the names. So if the immediately large network has been implemented, so manually it is very difficult to add the route in that particular network. So that is what one of the disadvantage. The system administrator should have a good knowledge of a topology, as he has to add each route manually. Topology is nothing but we are having different topologies: mesh topology, tree topology, star topology, bus topology. Which topology is going to implement in this? They have the good knowledge. The maximum time we are going to use a star topology. The star topology is very good for implementation of this routing. And the next routing is a default routing. Default is nothing but if that particular route is under maintenance, it is not that much good, it has to take the alternate routing. It has to take the alternate routing. It is a default routing is only one single exit point is there. Single exit point. So that exit point only you have to cross that particular destination. You have to cross that particular exit point itself. Default routing is a technique in which a router is configured to send all the packets. It has to be configured to send all the packets to the same hop devices. The exit point is only one. You have to send all the devices. You have to send all the packets in the same hopping devices, and it doesn't matter whether it belongs to a particular network or not. It is coming from different networks also. It doesn't matter, but only one exit point is there. Through that exit point itself, you have to move. The packet is transmitted to the device for which it is configured in a default routing. That has to be decided by this default routing. The default routing is used when networks deals with a single exit point. Default routing is used when networks deals with a single exit point. That is what the condition of this default routing. It is also useful when the bulk of transmission networks has to transmit the data to the same HP devices. Whenever you're sending the bulk of data, we are receiving the bulk of data from the different networks. That has to be executed through the single exit point. That has to be recorded in the routing table. So that routing table is going to help for this particular destination. For this route, you have to reach that particular destination. That is what the meaning of default routing. And the last one is dynamic routing. Dynamic routing is also known as adaptive routing. It is also known as adaptive. The static routing is known as non-adaptive routing. The dynamic routing is known as adaptive routing. Adaptive routing is nothing but we can add new routes also. If the people are becoming more day-to-day life, if the packets are increasing day-to-day life, we can add immediately, we can add the new route to give that particular packet to reach a particular destination. That has to be used in this dynamic routing. New routes has to be implementing to reach a particular destination. In dynamic routing, we are using routing information protocol. Information protocols and open shortest path first. You are going to open the shortest path first for sending the packets and discover the new routes. We are going to discover the new routes and we are going to open the shortest path. If any route is busy, if any route is goes down, immediately there will be a adjustment is there. Automatic adjustment has to be taken care if the any route is goes down, though, to reach the particular destination. Anyhow, that packet has to reach the particular destination. It cannot lose. It cannot be lost in between. If any route is goes down, automatically we have an adjustment. You have an alternative route that has to be taken care by this dynamic routing. What are the features? Same dynamic routing in order to exchange the routes. If packet is moving in this route, if you don't want to send the route packets from this route, we can send the another route also. We can exchange the route also. If the router discovers any change in the condition of the topology, then router broadcasts this information to all other routers. If the packet is moving in another direction, in another topology, the router function is to broadcast to everyone. Means I am sending the messages in the group. That message has to be reached to everyone. So that is what the one message has to be broadcast to all the persons. That has to be taken care by these features. Advantages: it is easier to configure. And second is, it is the best way to select the best route in response to the change in the condition or the topology. Different topology is going to have a different routes. It is going to select the different routes. So the main function of this dynamic routing is to select the best route. Disadvantages: more expensive. More expensive is the initial stage and the bandwidth this is used more. It is a less secure as compared to default and static. Static is nothing but what? There is a fixed route is there. We can't change it. But security is more. It is less secure. We are adding new routes to send the particular packet. So this is what the concept of routing. This is what the concept of routing. Okay, we'll stop here and we'll continue with the next lecture. Thank you. Just a minute, I'll take the attendance. Four, five, six, seven. Rule number 8. 9, 10, 11, 12, 13. Rule number 13. 16. 22. 23. 26. She is there.
Yes, sir.
27, 20, 29, 30, 30, 33. 34. 39. 39. 40, 41. Rule number 40. 40. 42. 42. 42. 47. 49. 50, 51, 52. 53. 54. 55, 56, 57. 55, 56, 57. 60.
Yes, sir.
का रे ऍबसेंट नंतर फोन कर लेक्चर झाल्यावर 61 61 63 66 67 71 absent numbers 8 13 16 22 23 33 34 39 42 47 49 50 51 52 55 56 57 61 63 66 67 71. You can leave now.
So
A40.
A40
Okay.
40.
Okay.